Good morning. Can you guys hear me?
Yes, doctor.
Can see the screen?
Yes, doctor.
Okay. So, let us start the class for today. We are still in chapter 2. So far what we have done, we are still in chapter 2. In chapter 2, there are two kind of variables. One is discrete and another one is continuous. So in our previous four classes, in discrete we have seen probability, distribution, function or table or something like that. Normally function. Okay, if question, they will give you probability density function, and then we also went through cumulative. Cumulative distribution function, and after this we went through expected value, variance and standard deviation. We almost finished that. We almost finished discrete for discrete variable. Before we go for continuous, there's one example I need to go through with you. If you go through the tutorial, last class tutorial, I teach you until expected value and variance. If you don't know anything, you can ask me in the tutorial. Later, you can ask me. Now, for before I go to continuous variable, let us look at this example, the example I show you in the screen. This is example 1. Example 1 I didn't cover last tutorial because there are certain things I need to highlight there. In discrete variable, let's say I give you probability distribution function. So we will draw a table. Right now you should know that the question will give you probability distribution function. Out of that we need to draw a table so that we can see clearly what is the variable and what is the probability. Let's say here 1, here 2, 3 and 4. The probability here is 4 over 10, 3 over 10, 2 over 10 and 1 over 10. This is the normal probability distribution, the one we have gone through before. Now if I want to find cumulative distribution function, of course it's a capital F. We normally use capital F. And we will start with four over 10, and then what we do, we plus. Of course this 4 over 10 is for x equal to 1, and then we plus 4 over 10 plus 3 over 10, that would be 7 over 10. This one would be x equal to 2, and then you plus again from here to here. You take the sum, you will get 9 over 10, x equal to 3, and finally you will plus all, and eventually you will get 1 for x equal to 4. So this is how you find your cumulative distribution function. Okay, now this summation here you plus. Next time you just imagine like this. There's a number here 1, 2, 3, 4, isn't it? 1, 2, 3, 4. So how to find the cumulative function? From here to here, and then you plus from here to here. Let me put it down. And then the second one you plus from here to here. Third one you plus from here to here. Fourth one you plus from here to here. So that's how you get here like this. You can imagine like that also. And this how you find cumulative frequency for discrete function. Of course I ask you later on, you change this to double. I teach you how to change and once you change, you can erase this one. No need. Anyway, that is regarding interval. Now my focus is not that. My focus is when I give you probability distribution function, you can find cumulative distribution function. What you did, you plus. Now if I give you cumulative distribution function, okay, cumulative distribution function, can you find back probability distribution function? What do you have to do? Minuses, right? The reverse. That's where the example 1 comes. You have to do reverse, because all the way when you want to find mean and variance, of course we have to use probability distribution function. But in example 1, there is no probability distribution function. Okay, there is cumulative distribution function. So you have to use cumulative distribution function to find the probability distribution function. So let us do example 1 now, and we finish with discrete and we move on to continuous variable. They have given you the cumulative distribution function, so I'm going to write an expanded form. If x equal to 1, you replace inside here. X equal to 2, x equal to 3, x equal to 4, and here will be 1 and 0. If you expand this, if you replace 1 to 5 inside this function, this is what you get. I'm just expanding the cumulative distribution function so that we can see clearly what is the value. Now once you expand this, we can tabulate the probability distribution function. start from 1, 2, 3, 4, 5, all together 5. So the 1, you immediately take this one, write it here, you will get 6 over 5. For 2, what you have to do, you take the previous one, put it here, which is 14 over 50 minus the previous one, 6 over 50. So what you get? You should get 4 over, I simplify, 4 over 25. Do the same thing for number 3. For number 3 is this one, okay. $24 over 50 minus the previous one, 14 over 50. You should get 1 over 5. Okay. For you to get back the probability distribution function from cumulative, this is how you have to do. Number 4 should be 30 over 50, 36 over 50 minus 24 over 50. This is 6 over 25, and number 5 is 1 minus and this is 7 over 25. Okay, now you have the probability distribution function, and now you can find the mean. You should get 3.4. Just double check. Please do, and you can see whether you can get 3.4. Just double check. Try do and see whether you get 3.4.
Yes, sir.
Okay, good. Okay, many of you have done. You get good. Now if you want to find variance, for variance you need to find a expected value for x square this one you can simplify 3 over 25 if you want. If x square, then you have to multiply by all the square, so 2 square, just now 1 square, please check whether you get this answer. That is your variance. So that is regarding example 1. Example 2 I have done, and I ask you to go through these notes. It's quite easy, and I ask you to do this example 3 and exercise in class 1. I have given you the answer. If you have any problem, you can always ask me. Now we will go to continuous random variable. Hope you guys get this answer. Okay. Next page. CRV or continuous random variables. Now a continuous random variable is not by individual number. It will be given in intervals. Okay, if I ask you what is what is the continuous random variable from 1 to 5, then it is all the numbers, all the value within 1 to 5. There are infinitely many numbers. You see, 1 is one number, 1.1 is one number, 1.11 is one number, 1.1111 is another number. So there are many numbers. Okay, there are indefinitely many numbers within 1 to 5. Okay, so continuous random variable, in a way, for the time being, what you can see is, what you can assume is, they have decimals. They have many decimals numbers, okay, inside here. But if I ask you what is the discrete variable within 1 to 5, then the answer is 1, 2, 3, 4, 5. This is discrete. Okay, discrete we have done. Now we are going for continuous random variables. If the variables are continuous, 1, 1.1, 1.11 and so on until 5, there are many numbers, then how are we going to deal with the probability? How are we going to find the probability? Okay, these are the two conditions to see whether it's a probability density function. Okay, I would like to go back to the previous slide. Discrete, we have probability distribution function, cumulative distribution function, expected value, variance and standard deviation. For continuous, we do also have something like that, but it is not known as probability distribution function. It is known as probability density function. Only this name are differ. This one is different from this one. Okay, different. The others all same. Okay, this is cumulative and this one is expected value. These are the same thing. The only different terminology is probability density function for continuous. So we're going to see the same thing how we did for discrete. We're going to see the same thing in continuous, except for the probability density function, which have some different terminology. All right. Okay. The two condition for continuous random variables is almost the same. The probability must be in between 0 and 1. If you see the discrete thing, the first condition is the probability must be between 0 and 1, and summation, if you plus all the probability, it must equal to 1. In here, probability density function, you guys must know the basic integration. Okay, so hope you guys still remember the integration we learned in maths. Look at example 1. Let x be a continuous random variable . Let x be a continuous random variable. Fx is given like that. Show that the function is the probability density function of x. So first we're going to show whether this is probability density function or not. If the question is like this, what you have to do, you have to check the two condition. Check the two condition. For x over 50 and x takes the value from here to here, if you choose any x within this, you put it up here. Okay, so for example, I ask you to just do one example. Okay, if you choose any value, let's say you choose 0, replace here. What is your fx? 0, isn't it? If you choose 1.5, because here is continuous, you can have decimal numbers. If we choose 1.5, what do you get? 0.03. If you choose, let's say you choose the maximum number, still what you get? 0.2. Can you go choose x equal to 15? Can you do this? Cannot, because the x is only between 0 and 10. So this one cannot. X is only in between 0 and 10. So if you choose any number within 0 and 10, you choose minimum number is also 0. You choose maximum number, the maximum 0.2. You choose in between something, 0.03. All these values, you can see that fx is less or equal to 1. That is our first condition. Remember, our first condition is, for it to be a probability density function, the first condition is the probability fx is a probability. The probability must be in between 0 and 1. You can see here. You can do whatever you want. Okay. You can choose any value you want, not whatever you want, any value you want, and substitute inside there and get the value. You will see that the function is in between 0 and 1. First condition fulfilled. Now let us go on to the second condition. What is the second condition? If you plus for each one of them, if let's say it's discrete, let's say this is discrete, what you will do? If discrete means, what you have to do? From 0 to 10, what are the discrete numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the discrete number. Cannot take, and it cannot stand from decimal. Let's say it's discrete. So for each of them, you will find the probability. For 0 is 0, for 1 is 1 over 50, for 2 is 2 over 50, for 3 is 3 over 50. Like that, you find for each of them, and for you to prove it, the summation is 1. What do? You plus, isn't it? You plus everything and you prove it is 1 or not, something like this. You will do discrete. Okay, this is how you do in discrete. But for continuous, I give you some time to look at it, because I'm going to go next page. Okay, I'm going to next page. Now this is not discrete. Okay, as we know, this is not discrete. This is continuous. Continuous means the x value is here. We still going to prove the summation is 1, but in this case we cannot do the same method as discrete, because if continuous, the value here is infinitely many values. Okay, it can keep on going. For infinitely many value, you want to find one by one is impossible. Okay, it's impossible to find one by one, and you want to plus. So how are you going to solve this? There comes the integration. You integrate. Integration is actually a summation. Okay, integration is actually summation from infinitely many number. So if you integrate 0 to the function, if you still remember how to integrate, and you will get one. So second condition fulfilled. Therefore fx is a probability density function of x. You have to make sure you show the two condition is fulfilled, then it is a probability density function. We are still in example 1. I give you some time to look at it, or you want to copy this, can. Okay, let us go to next page. A. Find the probability of x in between 2 and 5. So continuous random variable you have to integrate. Integrate from 2 to 5. For discrete, what you do? You just substitute. You substitute the value, that is answer. For continuous, you integrate. Just double check whether you get this answer. Just to just for your understanding, this 5 and act 2, normally in the school they never teach you this, but it's supposed to be like this. X equal to 5, x equal to 2. Okay, this value is x actually. X equal to 5, x equal to 2. So whatever value is here must be in between 0 and 10. Remember this one, 0 to 10. But in the school, to simplify, they just write it as 5, 2. Okay, this 5 and 2, you must remember it is actually your x. Okay, let us move on to B now. Question B. Anybody get that answer? I didn't check this one. Yeah, so many of you get this answer. Okay, good. Now for B, you are integrating from m to 8. And they say this is 0.48. Ask you to find the value of m. So if you do this, if you integrate this, you will get m is equal to either 4 or m equal to negative 4. The answer is m is equal to 4 because x is in between 0 and 10. Okay, so the m is equal to 4. That is the answer. Alright, I suppose you guys have copied this or have seen this how I'm doing this. Let us move on to example 2 now. Find the value of h if the question give you, see here, if the question give you for discrete, if the question give you probability distribution function, ask you to find some variable h or k, something like that. One of the hint is the summation is you use this hint to find k. Same goes for if it is continuous and they give you probability density function and ask you to find k or some variables. Here same method, but for continuous we use the summation of integration of m, the f should be 1. In other words, the summation of probability is also equal to 1. Use this is your hint. Okay, so we are going to use that. find the value of h. The hint is if you integrate this function, it should be equal to 1 because total probability is equal to 1. So h is 3/16. Okay, this is A. Let us move on to B. In B, they have given you 0.5. In maths, we learned that this one can be split into this, so I'm going to rewrite this. Now since we have found the h, we replace the h inside the function. 3 over 16. If I want to rewrite the function now is just now h y square, isn't it? So what is our h? 3 over 16. Now if you try to solve this, please check whether you guys get this answer.
Yeah, doctor, we got
Okay.
it.
Okay, before we go to exercise class 1, you guys need some rest. Maybe I give you for 5 to 10 minutes. We start back at 9:15. Is it okay? You want me to continue? You want some rest? How? Okay, some of you get answer. Can I continue from this onwards, or you guys need some rest? Anybody?
I think you can continue it, doctor.
Okay, we continue then. Hope you guys have copied this. So this is now we are in exercise class 1. 11 over 27. Now normally here there will be two value, so that when you integrate you will put two value here, but in this case we only have one value, which means let's say b is here and the smallest value is b, and the x go greater than b all the way. So up to which value you have to stop? Of course b is minimum, so you have to write b is here. Okay, b is small number, x greater than b, all the x go above b, greater than b, up to where? You see the question is until 2 to 5, so the b must be in between 2 and 5, and b can go up to 5. The maximum value for the x, whereby it is greater than b, and the upper limit is 5. You see the upper limit. Okay, let's say the question is like this. In this case, the limit is 2 to 5. B is here, let's say b is here, and all the x is less than b, isn't it? Less means go down. Up to where it can go down? Up to 2. So the integration must start from 2 to b. This is one case. Of course this is not our question. Our question is this one. If b greater than, the x value is greater than b, what is the upper limit? What is the limit the b can go? Up to 5. So b x integrate b to 5. In integration we can take out the constant. You can divide by the constant. I'm integrating now 5 to b. This is the answer. Let me know whether you guys get this answer.
Yes, doctor.
Okay.
Yeah, doctor, we get it.
Okay, now I suppose you guys have copied this. Now let us move on to question B. Okay, find the probability that for x in between 1 to 4. Here you need to understand that the fx our fx is only defined to 2 to 5. Okay, even though they ask from 1 to 4, but then you have to remember our x is only defined from 2 to 4, so we only can consider from here to here. From 1 to 2 the answer is 0. From 2 to 4 the answer is, the thing is fx. Okay, we can consider fx because the fx is only, sorry, not here 4, here 5. See, the fx is in between 2 to 5. The question is 1 to 4. We can only evaluate the probability for whichever x in between 2 to 5. Okay, so if you notice here, it is 1 to 4. 1 to 4 is from here to here. We can only evaluate from here to here. This one we cannot evaluate. This one is 0. Okay, you have to understand that. So we need to split this. How are we going to split this? From 1 to 2 the thing is the function is 0. Only from 2 onwards it starts from the function where we can define here like this. So this is automatically become 0. You can ignore that. You only have to evaluate 2 to 4 fx is 1 and our fx is if you do this, your answer is 216/27. Okay, I suppose you guys know how to do this integration. We have done many. For p x less than 3, I told you just now, the interval given in the question is 2 to 5. 3 is somewhere here. If the you can notice that all the value in x is less than 3, so it's going down here. Up to where it goes? Up to 2. 2 is the limit. Okay. So this means you integrate 2 to 3 and your answer should be 7/27. In the previous question there is a sketch. Never mind, you don't there's a sketch. Never mind, you don't need to sketch. I just ignore it. I give you some time to look this question and we can move on. Once you guys finish, we can move on to exercise 2. Let us move on to exercise 2. Find the value of k and sketch the graph. Sketch, no need to sketch. Okay, find the value of k. I told you the clue is the summation the clue is is equal to 1. This is a clue. From 0 to 2, the function is kx, plus from 2 to 4, the function is must be equal to 1. This is the idea. If you integrate this, and if you solve this, if you substitute and try to solve this, your k is 1 over 4. You try, okay, later on you try. For b, this is 1, 2, 3. If you notice, 0 to 2, 2 to 4, this one is the function is kx, or in other words x over 4, the function. For 2 to 4 onwards, the function change, whereby it is 1 over 4, 4 minus x. 1 over 4, 4 minus x. Okay. Now in this case we need to split, because 1 to 3 is no one function. Okay, 1 to 3, if it represent one function, it should be easy. We now have two function for two different interval, so you have to split 1 to 2 and 2 to 3 is another function. And if you do this, you will get 3 over 4. Okay, I suppose you guys have copied this. Now let us move on to next section, cumulative distribution function for continuous. If you guys need some rest, let me know. A cumulative distribution function. If let's say, look at the example 1, let x be a continuous random variable with probability density function is given there. Find the cumulative distribution function of x. First we have to find the cumulative distribution function. The interval given here is the, see, listen, this is the, I'm going to show you the method how to find cumulative distribution function for continuous random variable. The interval given there is 0 and 1. Okay. Now if I want you to do in density function, density, in the discrete, what do you do? For the first one you find this, for the second one you plus this, third one you plus this, am I right? That is discrete, you just plus. For continuous is a little bit different. We go by interval, okay. In the question they give you 0 to 1, so here all the way here it goes to infinity, here it goes to negative infinity, small number, this one go big number, okay. Remember the Cartesian equation, this one go big number, this side go, this side goes to negative infinity, small number, okay. That's how we see. Now if you notice here, there are 3 intervals. This is one interval, first interval, this is second interval, this is third interval. Let us consider the first interval. We are going to find the cumulative distribution function for the first interval, okay. So I'm going to integrate from here to here, somewhere here, and I want to stop here. Let's say this is your t, some variable inside here, t. I want to see what is my summation from here to here. This is variable t. So we are going to look at interval by interval. The first interval I write it as x less than 0 because it's less than 0, so I write x less than 0. Any value in this interval, if I choose, let's say t, any value t, you are integrating from negative infinity to t. What is the function? The function is 0. Why the function is 0? Because you see this 2x function is only valid from 0 to 1, this interval, second interval, not the first interval, the second interval. Okay, so the first interval the function is 0, because otherwise it is 0. So what is the value here? 0. Now we move on to second interval, which is 0 to 1. Listen carefully. We finish this one. I put like this, no? This one I put infinity, this one I put negative, this one positive infinity, this one negative infinity. We are moving to the second interval. Let's say I integrate from here, somewhere here. I stop in the second interval, whereby my variable is t. So from where to where I integrate? I will integrate negative infinity to t. Some function is here. Or in other words, let me simplify that. I will integrate from here to here first, because there are two intervals now, isn't it? I split that. 0. The function is 0. No function there. There's no function. And then I will integrate from 0 to t. Do we have function there? Yes, because it's the second interval. Second interval, the function is 2x. This one is automatically 0. If I do this, and this one will give me t square. Now, second interval finish. Now, can you guess which interval now? X greater than 1, because it's going this side, greater than 1. So, I'm going to integrate from here to here, and I stop somewhere here up to here. Now, how many intervals I have? First interval, what is the function? 0. Second interval, 0 to 1, what is the function? 2x. Third interval, from 1 to t, what is the function? 0, because there's no function otherwise. The 2x is only valid from 1 to 0 to 1. So this one becomes 0. You don't need to write. This one become, see, this part will become 0. This part will become 0. Left is only this part. And if you do this, you will get 1. If you see a function is 0, it's automatically 0. Okay, that's it. We have done. We see the intervals. From the interval, we see how many intervals are there. 1, 2, and 3. For each of the interval, we found the function, the cumulative distribution function, and we're going to summarize now. Okay, I give you some time to copy or see this. Now, if we want to summarize this, the cumulative distribution function, first of all, you write like this. Ft there are three intervals. First interval is this right here. Second interval is this. And third interval is here. It's just I would like to do some amendments here. Once you write, if you put a equal here, here don't put a equal, and if you don't put a equal here, put a equal here. See, T1, T1, isn't it? 2 T1, T less than T and 1, T and 1. If you don't put a equal here, then you put a equal here. Okay. If you put a equal here, then you don't put a equal here. Okay, both can. I allow you to do that. Same goes for 0 and T. Integration, when you put equal or no put equal, it doesn't matter anyway. In that case, let me put it here. Maybe I change the interval like this. Okay, doesn't matter. We just for mathematical purpose we need to comply this. So t less than 0, 0, 0 to 1, t square, t greater than 1, 1. Once you write the answer in t, you rewrite back again the answer in x. Okay, this is how I teach the students. Okay, once we write in t and then we write in x, but if you don't want to write this, you want to write this straight away, x also can, no problem. So the answer is, this is the answer. Cumulative distribution function is, this is the answer. we will do one last question, and then in tutorial, if I manage to finish the tutorial, I will continue this class in the tutorial. Okay, I suppose you guys have copied this. Before, in the example 1 here, there are some question A, B, C, is it? That one leave it first. Go to example 2, because I want to make sure you guys understand how to get the function. Okay, the question in example 1, question A, B, C, we have to answer based on the cumulative distribution function we get here. That is quite easy, we can do that. But first of all, I need to make sure you guys know how to get the cumulative distribution function for continuous random variables. So for that, we practice one more in example 2. In example 1, for the question A, B, C, I will come back again to guide you. Don't worry. Okay, so example 2, first of all, what we did, we split the interval. Question is, find the cumulative distribution function first. So the interval is start from 0 to 4. And then 10 and 14. Okay, now remember the function 1 over 12 is only from here to here, and 1 over 6 is only from here to here. The function in other intervals apart from this are 0. You have to remember that. So if I split these, how many intervals I have? Of course, here infinity, here negative, infinity. I have one interval. The class going to finish, almost finish. No point you coming in the last minute. Sorry to say that. You can see the video anyway. Now we are going by interval. First of all, x less than 0. I put s less than 0 because there's a equal here. Okay, there's a equal here. You can see here there's a equal. So I put s less than 0. Don't need to put equal here. So I'm going to integrate from here to here. I stop here somewhere. So my t is here now. So I integrate negative infinity to t. What is a function? Function is 0. The answer is 0. Okay. The first interval done. We are moving to the second interval. Here we have equal because there's a equal here. Oh, in that case, sorry, I need to do some changes. Just give me a moment. Because in the previous question, this one has no equal, so here equal, because we follow the question. I just remember that. So according to the question, there's no equal here, there's a equal here, there's a equal here. So we follow the question. Question is, for this interval there's no equal, isn't it? So the other interval have equal. Okay. Next interval, example 2. I'm integrating from here to here. I stop here. From here to here. Zero plus, sorry, this is 0 to t, and from this interval the function is 1/12. If you do this, the part with 0 is automatically 0. If you do this, you get this, and this is t/12. This is done. Now we are moving to third interval from here to here. The t is somewhere here, so the interval now is, put a equal here, because there's no equal here, you put a equal here. X 10, so you have to go through 1, 2, 3 integration, negative to 0, 0 to 4, and 4 to t. Okay, negative infinity to 0, the function is 0. 0 to 4, the function is 1/12. 4 to t, you see this interval 4 to 10, there's no interval here. 4 to 10, there's no function here, so this one also 0. Here 0. So if you do this, you get 1/3. We are going for the third interval, sorry, fourth interval here. So how many intervals you have to consider? We are going here, fourth interval. You can see there's a equal here, no equal here. Fourth interval, how many interval? 1, 2, 3, 4. The function here is 0, the function is 1/2, the function is 0, the function here is 1/6. Zero to 0 to 4 is 1/12, 4 to 10 is 0, and 10 to t is 1/6. Okay, if you do this, you will get 3 minus 8 over 3. Yeah, you can try, you can do this and try this on your own. The final one is x. Okay, I'm going to try from here to here. My t is in the fifth thing, and if you do this, you will get, okay, if you do this something, you will get 1. Okay, I give you some time to copy this. You can do the final part later. Copy this. Okay, hope you guys have copied this. The final answer you have to write in summary. This is the final answer. Okay, we will stop here. We will stop here, and I'll see you guys in the tutorial at 11 and 2. If I manage to finish the tutorial earlier, then I will continue the class. Okay, I plan to finish this by today, but anyway, we will see how far we can go. So with that, that's all for today. Thank you very much. I'll see you guys in the tutorial.
Thank you,
Bye.
Doctor.
Yeah, bye.
Thank you, Doctor.
Thank you, Doctor.
Okay.